Aboard a floating airport like the U.S. Navy's USS Carl Vinson aircraft carrier, hundreds of millions of dollars of equipment and thousands of lives are all managed by something that looks like a board game. Called the Ouija board, it's an analog system in existence for decades, and it's how sailors keep track of where planes are and where they're going. Researchers at MIT are hoping they can digitize that system, make it more efficient, and reduce any chance for error.
So the system that we're working with is called the Deck Operations Course of Action Planner. It's Navy-funded research that primarily is investigating how humans and computers can work together and schedule operations on the aircraft carrier deck collaboratively. So rather than being just a human or just a computer to do it, how we can get them to work together and really use their own strengths in order to create better, more efficient, and safer schedules of operation.
The DCAP system will keep track of equipment and people on deck using RFID. In one room on campus, the group has a digital representation of an aircraft carrier deck, including people and machines. Whoever is in charge of scheduling can move aircraft forward or backwards in the schedule, and the entire system will adjust. It will also reschedule operations should one of the catapults that launches aircraft stop working. In another building on campus, the research team has built a small-scale model of an aircraft carrier with moving models, all controlled by the DCAP system. Its purpose is to launch all the models and bring them back to land. Ryan said that in terms of next steps, he and his team want to focus on safety within the system, while writers of the algorithm will continue research to perfect it. A third team is working on gesture recognition so that UAVs or unmanned aerial vehicles could understand the hand movements used aboard the ships.
The third branch of the program, which I mentioned earlier in the conversation, doing the gesture recognition, so teaching a UAV to understand that this is move forward and this is turn left. He's continuing to work on that. They've done some great proof of concept stuff. A guy in a room under standard lighting, system performed remarkably well, better than 94% accuracy in one case. Problem is, on the aircraft carrier deck, you have sun glare. You have a bunch of different people running around. The background is changing. When things launch, you have steam roll off the catapult that completely occludes the field of vision. So he and his professor are working now on making the system robust, teaching it to differentiate between me and you and understand that only one of us is talking to you right now and better able to handle all those environmental factors.
Ryan said he doesn't imagine a system like DCAP going into operation for about a decade because it will need to be tested to work flawlessly under both a controlled environment and in wartime. At MIT in Cambridge, Nick Barber, IDG News Service.